The prediction of a massless neutral composite particle named Demon, which was made 67 years ago, has been confirmed by physicists. Back in 1956, David Pines, a physicist with a theoretical background, predicted that electrons in solids could display a peculiar phenomenon. Although electrons are typically characterized by their mass and electric charge, Pines posited that they could merge together to generate a composite particle that is both neutral and massless, a phenomenon he labeled a demon. Since then, it has been theorized that this particle could potentially have a significant impact on the behavior of various metals. Unfortunately, the same attributes that render it fascinating have also made it challenging to detect, and it has remained elusive since its initial prediction. After 67 years, Peter Abamonte, a physics professor at the University of Illinois Urbana-Champaign, has led a team of researchers to discover Pines's demon, as predicted years before. In their report in the Nature journal, the team discussed their use of a non-traditional experimental approach that stimulates the electronic modes of a material directly. This stimulated approach allowed them to observe the unmistakable signature of the demon in the strontium ruthenate metal. According to Abamonte, the concept of demons has been a subject of theoretical conjecture for quite some time. However, experimentalists have never had the opportunity to study them. Interestingly enough, they were not even searching for it. Despite this, it turned out that they were conducting the proper procedure, and they ultimately discovered it. A significant finding in the field of condensed matter physics is that electrons in solids lose their distinctiveness. This is due to the electric interactions that amalgamate the electrons to create collective entities. The energy required for this process is substantial, and with enough energy, the composite particles they form are referred to as plasmons. These plasmons possess a unique charge and mass that is determined by the electric interactions that underlie their creation. However, the mass of the plasmons is usually so great that they cannot form under normal room temperature conditions. Pines discovered a unique exception. He posited that if a solid contains electrons in multiple energy bands, as many metals do, their corresponding plasmons can unite in an out-of-phase pattern to generate a new plasmon that has no mass and is neutral, known as a demon. Because demons are weightless, they can exist at any energy level, making it possible for them to exist at any temperature. As a result, there is conjecture that they have significant impacts on the conduct of multi-band metals. According to Abamonte, the neutrality of demons implies that they are not detectable in standard experiments that deal with condensed matter. Although most experiments rely on light measurements to gauge optical properties, demons, being electrically neutral, do not interact with light. Therefore, a completely distinct experiment is required to identify their presence. During his recollection, Abamonte reminisces that he and his fellow researchers were investigating strontium ruthenate for a purpose unrelated to its superconducting properties. Despite its similarity to high-temperature superconductors, it is not one itself. The team was conducting their initial assessment of the metal's electronic properties in the hopes of uncovering insights into the origins of this phenomenon in other materials. Yoshi Maeno's research team, led by the physics professor at Kyoto University, produced high-grade samples of the metal which were later studied by Abamonte and former graduate student Ali Hussein using momentum-based electron energy loss spectroscopy. This unorthodox technique utilizes electron energy to observe the metal's qualities, including the formation of plasmons. During their analysis, the scientists stumbled upon an unexpected discovery, an electronic mode that had no mass. Hussein, who is presently a research scientist at Quantinuum, reminisced, saying, "Initially, we were completely clueless about what we'd found. Demons are not a commonly referenced phenomenon. We even dismissed the possibility of it early on and laughed it off. However, as we began to eliminate potential explanations, we began to strongly believe that we had indeed discovered the elusive demon." The researcher Edwin Huang, who holds a Moore postdoctoral scholarship at UIUC and specializes in condensed matter theory, was eventually tasked with computing the characteristics of the electronic structure of strontium ruthenate. Huang explained that the prediction of demons by Pines requires very specific conditions, and it was not evident whether strontium ruthenate had such a demon at all. Therefore, it was necessary to conduct a microscopic computation to clarify the situation. Following this analysis, it was discovered that there is a particle made up of two electron bands that oscillate out of phase and with nearly identical magnitude, as Pines had described. Abamonte asserts that his group's discovery of the demon was not a mere coincidence. He stresses that the technique they employed was not commonly utilized, and the substance they were examining was not well researched. In his opinion, the discovery of something unexpected and substantial was a direct result of their decision to try a unique approach. The significance of accurate measurement cannot be overstated, he commented. Many pivotal breakthroughs are not the result of predetermined efforts. Instead, they emerge from exploration of uncharted territories, revealing new and unexpected discoveries. Assistance was granted by a variety of organizations, including the US Department of Energy, the National Science Foundation, the Japan Society for the Promotion of Science, and the Gordon and Betty Moore Foundation. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.